So yeah, so Bronsted Lowry acids and bases. Hopefully, uh, hopefully it's not too difficult concept, and then the work that I gave you, it's only there's only 10 problems here that you need to figure out, so it's not a ton of work to do today. But you have the quiz to do as well, so that's kind of why I have it just an easier assignment today. Okay, so basically, we talked about the definition, the Arrhenius definition previously about the Arrhenius definitions of acids and bases. So the Arrhenius definition is that an acid is something that gives off H plus in water, and a base is something that gives off OH minus in water. Okay, so really simple. If you see it H plus, or you see an H at the beginning, that is an acid. If it has OH at the end, it is a base. Okay. Okay. There's another definition of acids and bases. It goes along the same lines here. It's the Bronsted-Lowry definition. Okay, so in the Bronsted-Lowry definition, the acid part is actually the same. So let's give it a second here to load. So the acid part is actually the same. Okay, acids are species that give off H plus ions in water. So the same as the Arrhenius definition. Okay, anything that gives off H plus ions in water. Okay. Bases, however, bases are anything that accept H plus ions in solution. Okay, they neutralize acids. So anything that neutralizes this H plus. So we kind of have to look not just at the molecule we're looking at, but we have to look at the overall acid-base reaction. Okay. And this includes OH minus, because OH minus will combine with H plus to give you H2O. Okay, but it also expands the definition a bit further. Okay, so we'll see that there's other things besides OH minus that count as bases. Okay, acids still the same definition. Bases are a little bit different. Also, so acids and bases, those are going to be found on the reactant side of the equation. On the product side, we have something called conjugate acids and conjugate bases. So conjugate acids are species that are the results of the base gaining H plus. All right. You can also look at the reaction backwards and see what donates an H plus in the reverse direction. So we're going to look at some examples, then I'm going to explain what that means. But and then conjugate bases are species that are the result of acid losing H plus. A way you can figure out what the conjugate base is, you can look at the backwards direction. So the reaction in the backwards direction, and see what accepts H plus in the reverse direction. Okay, so let's look at some examples here. It'll kind of make this a little clear here. So we have HNO3 and OH minus. Okay, in the forward direction, HNO3 goes from HNO3 to NO3 minus. So it donated an H plus. Okay, you also see it just has that H plus there, so it's pretty easy to distinguish which one's the acid because it's always going to have the H plus in the beginning. Okay, OH minus, that was easy because OH minus is always a base, right? So we have our acid and we have our base in the reactant side. Always on the reactant side is acid and base. In the product side, we have conjugate base and conjugate acid. So it helps if we look backwards. So NO3 minus, what does NO3 minus do when it goes over here? Well, it takes on an H plus. So NO3 minus becomes HNO3. If it takes on an H plus, therefore it is the conjugate base. Okay. It's also the result when the acid loses that H plus, it's what results from that acid losing the H plus. That's the conjugate base. Okay. And then this base gains H plus, we become H2O. That makes this the conjugate acid. However, you look backwards, H2O, it loses H plus to make OH minus, so therefore it is the conjugate acid. So look at it backwards. H2O goes to OH minus. It gave up an H plus. It's the acid, but it's in the product side. So there you go. That's how I like to look at it. I like to look at it backwards. I don't really look at it necessarily the way the definition describes it here. Okay. The next part, this one, another example here. We have H2SO4 and H2O. Okay. H2SO4 gives up, if it goes H2SO4 to HSO4, gives up an H plus, therefore it's the acid. Okay. H2O takes on an H plus to become H3O plus. So therefore it's the base. All right, if we look backwards, H3O plus goes to H2O, gives up an H plus, therefore it's the conjugate acid. You also think of it, the base takes on an H plus, that becomes the conjugate acid. Then last one here, conjugate base. The HSO4 is the conjugate base because it's the result of the acid losing H plus. You could think of it that way. Or you could think of it as, if it goes backwards, the reaction goes backwards, HSO4 takes on an H plus to become H2SO4, which is the base. So the conjugate base. So you can think of it, again, one of two ways. The result of the acid losing the hydrogen, or if you go backwards and you look at the base, it's a base because it gains an H plus. So you can look at it one of two ways again. Okay, last example here, HCl plus H2O. HCl has that H, gives up an H to become Cl minus, so therefore it's the acid. H2O takes on the H plus, therefore it's the base. Okay. Then you could think of HCl loses H plus, so the resulting is Cl minus. Now it's the conjugate base. Or you can think of it backwards. Cl minus takes on an H plus, therefore it's the conjugate base. Okay. Same thing here. H2O gains an H plus, so this is the conjugate acid. Or you think of it looking at it backwards. H3O plus gives up a proton in the backwards direction to become H2O, therefore it's the conjugate acid. Okay. So that's it. That's how you do it. That's how you do conjugate acid-base pairs. Okay, and your job now is to just fill out these charts right here. Do the best you can. All right. So remember, acids and bases will always be in the reactants, and the conjugates will always be in the products. Okay, just don't forget that. And then there's a little description right here about what each one does. So there you go. All right, so that's it. Good luck on that. Don't forget to do the solutions quiz as well. All right. And then if you have any questions, feel free to stick around and ask. Otherwise, you all are free to go, and I'll see you tomorrow.